Hello, I'm Professor Birdwell, and this will be a video module on how to do the fundamentals of applying dimensions to an orthographic multi-view drawing.
In this case, it'd be a drawing of the little truck which you have been introduced to you beforehand. Okay, so here's the multi-view of the truck. Now, the question is, how do you dimension this? Dimensioning is a very critical piece of the action for an engineering drawing, for it is in fact the major means of communication in terms of information to the builder and fabricator of almost any object. So how do you go about doing it? Just throw dimensions in. If you've read your text, you'll understand that you must go to dimensioning with care and precision. You use as few dimensions as needed to fully describe the object, no more. You don't repeat dimensions in any case. They are unnecessary and redundant. In a very complex drawing, you may have a great many dimensions, so you can understand why there's a real need for economy in this regard.
We should also say you don't have to dimension every view, even though you have 3 different views in your multi-view drawing.
In the multi-view drawing, what is referred to as the front view is always the view that shows the most descriptive detail of the object that you're concerned with. In this case, here it is right here, okay? So let's begin to dimension this in terms of overalls. Now, I advise you, first of all, to begin with your smaller dimensions. Well, what does that mean? Well, using witness lines. Why are these called witness lines, do you suppose? Well, the answer is they are witness to the fact that they align exactly with that vertex. Let me do another line. I'll do a somewhat shorter one here. All right, there's a witness line. Now, between those 2 lines, there's a given distance. And that is drawn strictly vertical with arrowheads that are on like a 5-to-1 ratio, sharply pointed, very clear, pointing exactly to the witness line, which is exactly aligned with the vertex that you see here. And in this case, we know this is 1.5 inches. All right, well, let's put in 1.5 inches. You will notice I did not put in, and will not put in, any inch marks, anything of the sort. That information is carried down in the title block. It says we're using inches. So we know that's a 1.5 inch, all right? Well, how about the height here? Well, again, let's get a witness line here. You must always go to witness line. Start just short of the vertex, bring it across, and come again with a witness, or a dimension line.
Notice here, your witness line will not touch the feature that it is bearing witness to. So there's a small gap. The dimension line, which has the arrow on it, will touch the witness line, right? So the arrow does touch the witness line. The witness line should not touch the feature that it is dimensioning off of.
Okay, so this is 1.5 inches, and we said the overall is 3 inches. Do I need a dimension here? Well, no, I don't. 1.5 out of 3, that leaves me 1. I know that's 1.5. The one I'm interested in is this one, from just short of that point coming up. I come up with a witness line, and I will put in the dimension up here. That is done in this manner, and that is 1.25. Now, I've pretty successfully located that point, and that point relative to an overall size. Well, how about the length of this thing? This is way back here, and how about this? Well, let's simply extend the first witness line. You always go back to that. All right, that's going to do this, just short, all right? Take a second line, which says, okay. I would like to just simply do it this way. I can do it several ways. This is the easy way. I'm going to draw a witness line, and I'm going to draw this, and I know from measurement or by assignment, simply say that's 4 inches. Again, the arrow, all right? That's 4 inches. Now, you'll notice I'm using 2 places. Wherever there are 2, it's not just 4. If you're 1.25 inches here and you're 4 here, leave 2 decimal point holder blocks, okay? So it's consistent throughout. Okay, well, having given you 1.5 and 3, you know this is 1.5 inches. You know this is 4. Okay, we can draw that line. We then can draw these 2 lines without ever knowing what the angle is. We don't care. It's dimensioned in. Same holds true as we go through other elements of this. How about locating this point? We can do that very simply with another witness line. Comes out here at some convenient location. Clear of the object. You never draw inside the object. Locate the dimension line, and we know that that is 1.25 down by measure, all right? So we have located this way, but how about this way? Well, looking at this, I know that that is a 1/4 inch shorter than the 4-inch overall. So what I'm going to do, I'm going to alter some things here. I'm going to alter the dimension, keep most of that witness line, come to this witness line, and I'm going to go in on the shorter of the 2 dimension lines and call that 3.75. Well, I lost this dimension, didn't I? I got to go back and I got to put that back in again, all right? So the fabricator will know that that point is exactly 4 inches out here. So that's, again, 4 inches. Okay. Now I've spelled out just about everything I need to block out this whole thing, but we don't know, what is this? Is that a through hole? Is it, no, it's not. What's its diameter? How do I show it? Come in at a convenient angle. You start here, up, and over, just a little bit. Put an arrow that points exactly to the diameter of that circle. Use the conventional diameter symbol, which says diameter is, in this case, 1 inch. Okay? Now often you'll find smaller arrows are introduced here just to further reinforce the fact that it's a 1 inch circle. We can also say by notation how deep that circle is. Let's say you put it in brackets and we'd say circle is 0.25 deep. We don't have to go into a lot of language about this and describe it as a circle and it's kind of deep. It's a 1 inch diameter circle located precisely at this location, and it's 1/4 inch deep. Do likewise for everything else. The same holds true for the wheel wells. The diameter line always goes through the center of the circle, as you will notice. Okay, so I'll say this is a diameter, 1 inch. Okay. In this case, however, I use an arrow here, so it's very clear. That's a diameter. I don't need to say it's 2 places. Perfectly obvious that those are the same. All right.
Quick correction. That's a radius, not a diameter.
You're right. Sorry.
This is actually good. You can see what both of the notations look like.
That's a radius. Okay. Radius is 1 inch. And from my sorry example of just a moment ago, it points out how very careful you need to be. Okay. All right, so what have we got here? Well, we don't know where these 2 wheel wells are located, so we obviously are going to have to show that as an important dimensional feature. Well, witness lines again come into play. There's a witness line starting just short of that, coming down. I want to know where this first center is located. All right. Well, I know that's 1.25 inches right there. So I very carefully put in my arrows. I leave a space for the number. There's 1.25, and I've located that exactly. But whoa, wait a minute, it's up in the body. What is that? Well, that again, we got a witness line over here. We're 1/4 inch up. Now we put arrows on the outside because we don't have room to put it inside the brackets. We do this, and we say that's 0.25 inches, okay? I now have precisely located that point. I've spelled out the radius. It's clear that that's a straight line up to here before the radius is introduced. And I can come back over here to this and say the wheel well is exactly 1/2 inch deep. So simply put in brackets, put 500, and then say deep. You have now spelled out the detail for that. The last remaining dimension you need is where do you locate this? Well, again, a witness line. Go all the way back to this witness line up here. Come across. Little space for your dimension. Come to here. Nice clean arrows. Cleaner than what I'm drawing here, perhaps. Okay, so that's a distance I have to measure now because I've forgotten. That's 5 inches. So here's your 5 inches. I have now located every detail on this front view that would be required in order to lay this out on a block of wood and prepare to cut it and fabricate it. What's missing on this? Well, a couple of things. Number one, how wide is this? Well, we know by actual measure that the width of this, so we'll go to this view, because that is obviously the end view. Come across here, lay in your dimension. Try to give as much space away from the object as possible, okay? And then we know this is 2 3/4 wide, all right? I now have enough information to cut out a block of wood that would be exactly what you would need in order to create this. The only missing object really are these 2 circles. Those circles are inlets for the headlights. You can see in the side view it's hidden, but you can also see a center line. That center line projects straight across there, and they're over here. Okay, so what we need to do, we just need to spell these out. Well, let's tell the observer exactly what is going on here. First of all, we want to know there is a 1/2 inch circle. I use, again, the convention for circle. Okay, it's 1/2 inch. I don't need to explain really that the other one is the same thing. It's clearly a symmetrical part. But you could say if you in important circumstances, if you had a lot of holes, you'd put in a notation that says 2 places, PLCS, places. That tells the observer there's 1/2 inch holes, 2 places, and we'll say they are a 1/2 inch deep. A lot of information in a very short little space, critical, okay? Now what we need to know is, well, where are they located? Well, it's symmetrical. Let's go from a line we know is from here to the center. What do we find out? Well, first of all, we don't have a lot of elbow room, so we're saying that's a 1/2 inch. I put the arrows outside the bracket pointing in, and I say that's a 1/2 inch. Okay, now I got a problem. Okay, how do I locate that center? Well, I get a witness line down here where the eye will lead you down, witness to the fact that this line right here that intersects the center of that circle is again 1/2 an inch exactly, all right? I now have created everything I need to know in order to make the frame of this little truck. Absolutely everything. Is that true? Not quite. What's missing? Well, look here. We forgot about the axle. Well, let's just come in. Let's take a dimension pointing to the axle point, and let's just tell them that that is a diameter hole of 1/4 inch, and it's a through hole. THRU, okay? Through hole, all right? Arrow. And I'm in business. I can go ahead and make it.
So a couple of things to point out here. One, this covers the fundamentals of how to place your dimensions and what the dimensions should look like. This does not include every single dimension that is needed for this part. A couple other things we'd like to point out. One, you'll notice that we've grouped our dimensions together here on this drawing, right? So we've got smaller dimensions placed closer to the object within larger dimensions. You can see that here, see that here, right? You should do this instead of placing the smaller dimensions outside of the larger ones. You should try to avoid crossing these witness lines with the dimension lines. If you nest the smaller ones inside the larger ones, this will avoid that. Additionally, you'll notice that we never dimensioned off a hidden feature. You should also attempt to avoid and never do this as well. Choose a view where you can see that feature head on and then dimension off of that view. So in this case, the headlight is hidden here. So we went over to this end view and we placed the dimensions for the headlight over on this view on the end view.
One last thing. Always dimension to the center of a circle. Always. Never to the edge. Okay, it must always be at the center. That's about it.
I think that covers pretty much everything. Please also refer to your textbook for additional rules and suggestions for placing your dimensions. And this will conclude the dimension module for this sequence.